Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Welcome back to the Health Upgrade Podcast. This is Dr. Habib. I hope you're doing well. I have to ask you a question. Do you think that your light environment that is in constant conversation with your vagus nerve could have an effect on your HRV? Well, today what we're going to do is answer this question. How does light affect our HRV? Your light environment truly is constantly in conversation with your vagus nerve, and through that, the timing of that conversation matters nearly as much as the light itself and certain characteristics of that light. The way we're going to go through this is I've reviewed a 2025 systematic review article from Neuroscience and Behavioral Reviews that pulled together 25 different studies on the effects of light and HRV. And the findings look a little bit contradictory at first, but as we work through it, you'll start to understand that there is a very strong relationship between light and heart rate variability. The real goal of this episode and of this content is to determine that we don't necessarily need to work to maximize HRV all the time, but rather to use light timing to regulate the circadian rhythm, and HRV improvements will follow as a downstream benefit to that circadian rhythm reactivation or re-regulation. Okay, so let's dig into the biology for a quick minute here. So light isn't just here to help us see, it actually activates a pathway, a second pathway via the specialized retinal cells. They're called intrinsically photosensitive retinal ganglion cells. And these are cells in the back of the eye and the retina. And they use a photopigment called melanopsin that is especially sensitive to blue light. That's the 480 nanometer wavelength light. And this pathway comes in, we have light that comes in through the eyes, it goes to the retina, and these intrinsically photosensitive retinal ganglion cells, also known as IPRGCs, will then send a signal through to the suprachiasmatic nucleus. This is the SCN, and this is actually within our entire brain. This structure is known as the circadian clock. This is where light comes in and tells our brain that it's time to turn on, that we are present for the day. We then have a signal that relays through the suprachiasmatic nucleus to the hypothalamus, and then from the hypothalamus directly to the dorsal motor nucleus of the vagus nerve in the brainstem. The key point here to take home is not that there is these specific structures, but rather that the pathway runs through your circadian clock on the way to your vagus nerve. And that then tells us that the effect of light on the HRV and light's effect on circadian rhythm are mechanistically the same pathway, not two separate things. So how light affects our HRV is going to be based on how light affects our circadian rhythm. The two need to work together, okay? There's two parameters that matter when it comes to light overall. Number one is the illuminance. That means the brightness, which is measured in lux, and then the color of the light, which is the wavelength of the light. Blue is at around 480 nanometers, and red light is around 640 nanometers. And then if you know the spectrum of light, it goes obviously from blue to red, and then goes into ultraviolet and infrared, and that's the light wavelengths that we can't see, but they obviously exist. So our visual system focuses on between this 480 to 640 nanometer pathway, and the wavelengths will play a different role in regulating vagus nerve and HRV. So now there seems to be a little bit of an apparent contradiction here. Now, the way that this works is acutely, this is important to understand. Acutely, when light enters the eye, when the light is high intensity, so quite bright, and more on the blue side of things, so blue being that 480 nanometer level, that blue cool light acutely decreases our HRV. it suppresses heart rate variability, and it shifts the nervous system toward sympathetic dominance. This is why a bright flashing light, even bright lights from our phones are going to create this experience of sympathetic dominance, of stress activation in the acute scenario. Low illuminance, so dimmer, warmer light, that's more on the red side of things, more closer to that 640 nanometer marker, is actually going to raise HRV. It's actually a calming signal. It's a calmness. Think of what you experience when you see a candle lit, a flame lit up as a candle, or a fire, like a campfire, for example, or a fire at a cottage, something along those lines. This is a simple version, but this is where most people stop. That what we're hearing is blue light decreases HRV and red light increases HRV. That's not the full picture. What we have to go and look at is, when is this light coming in and what is its effect longer term? So in 1995, Redklin et al. Found that depressed patients given morning bright light, that's between 6 and 7:30 a.m. for that study, for 14 consecutive days, showed HRV trends increasing by day 5 alongside mood improvement. In 2023, Petrowski et al. Also had a similarly timed exposure of light in the first 60 minutes post-awakening, and the same bright light that acutely normally would drop HRV was actually associated with improving HRV over repeated morning sessions. So bright light in the morning was found to increase HRV down the line, not acutely, not when the light came into the eye, but over time the HRV started to ramp up. What this tells us is that the acute HRV dip during that morning bright light isn't necessarily a side effect to avoid, but it may be part of the mechanism that helps to turn on the circadian rhythm. It actually is the same arousal signal that tells your suprachiasmatic nucleus that it's daytime now, and that re-anchors the circadian clock. That re-anchors you into that 24-hour rhythm. If you do this over repeated mornings, that circadian entrainment is what drives the baseline HRV mood improvements, not the light itself in any single session. So it's not about the acuteness of this light coming in, but rather the repetition of the pattern. And that repetition of the pattern on a day-to-day basis is actually what drives this to be a positive or a negative experience. So let's reframe this. Morning bright light is actually a circadian regulation tool first. The HRV benefit happens downstream, and it shows up over days, not over minutes. Really important to note. So let's think about how we would incorporate this into an implied protocol, for example. What we want to experience in the morning is bright, cool, blue-enriched light that acutely lowers HRV, but anchors the circadian rhythm, building towards improved baseline HRV over repeated days. We want to have blue daylight, bright morning sunlight. Sunlight being very intense. We'll get into the intensity of light in a moment. In the evening, what we want to potentially look at is a warmer, dimmer, red-shifted light, acutely raising HRV, and signaling wind down to the circadian system, which avoids delaying the melatonin onset. So when we have bright lights in the evening, that is actually a sympathetic activator that's telling us that it's still daytime. We don't need to convert to serotonin to melatonin now, but in fact we do. And so what we're doing is we're dysregulating the circadian rhythm when we have bright lights from our TVs, from our computers, from our cell phones in the evening time. And so what we need to do is work towards red light during the evening, calmer, not as bright. The brightness and the color are the two pieces that matter here. This isn't a universal protocol, though. I should very clearly state that what we should be looking at is that light, color, and intensity don't land the same way for everyone. So in a study in 2023, for anxiety specifically, Sergieva et al. Found that high illuminance blue light causes sharper acute HRV suppression in highly anxious participants than in calmer ones. So depending on how severe the challenge is that you're dealing with, how anxious you're kind of symptomatically currently in, Anxious and depressed patients found that even red light in 2011, Choi et al. Found that red light lowered HRV, the opposite of what it did in healthy participants. So people with significant anxiety may respond atypically to light color, generally not just to blue, and the instinct to teach for calming red light isn't automatically safe for this group. So practically what we need to do is people that are dealing with anxiety or anxiousness should try morning bright light for circadian regulation, but do it at a lower intensity, gentle, and build up over time rather than jumping to a high lux blue light. Don't just go outside first thing in the morning every day if that's not working for you, if you're dealing with this hypersensitive experience. Post-surgically, obviously, or medically compromised populations found, Ono et al. In 2011 found that bright light therapy produced no HRV benefit in post-esophagectomy patients when vagal function is already significantly compromised. Not surprising to me at all. And light alone may not move the needle, which we kind of understood. There's so many other factors that are coming in to determine whether we're in a sympathetic or a parasympathetic activated state. And overall, in a general caveat, all 25 studies in the review article were rated at high risk of bias, and most were smaller, short-term lab-based tests, not real-world. So the direction of these effects is fairly consistent, but the exact protocol and the effect of the intensity, the duration, how many days, all of that information is not yet established. So what do we actually do? How do we take this information and actually incorporate it into our daily lives? The way I like to think about this is, let's think about how we evolved as humans. How did we show up in this world of 24 hours of light and dark, rhythmic factors? And how did we do so before the advent of technology, of incredible, wonderful connecting tools, but we've actually become more accustomed to those lights being present all the time. And that is where the issue pops up. So how do we get back into this re-regulated lifestyle of not being stuck in these artificial light states at times when the light shouldn't be present? Number one, morning time. That first 60 to 90 minutes, first thing in the morning upon waking, is the moment where your full circadian rhythm is regulated. When we re-regulate using bright light, blue light, ideally sunlight showing up first thing in the morning, going through those intrinsically photosensitive retinal ganglion cells at the back of your eye, go to your suprachiasmatic nucleus and reactivate that system. What we're then doing is we're getting back into the system of it's daytime now. And this is where we should be turning on. The problem is if this occurs at other times during the day. So if at 10 p.m. you're sitting there and you've got your cell phone in your eyes and it's blaring this bright blue light directly into your eyes, we're telling our brain that it's daytime even though it's time to wind down. And that's where the issue pops up. So morning time, focus on getting bright light exposure, ideally with blue content, but that content should come from ideally in the optimal scenario, just opening the windows, going outdoors for a moment, getting fresh air, getting that beautiful blue sunlight, daylight right upon those first 30 to 60 minutes of waking. What you may see if you're measuring your HRV is a quick dip in HRV. We do know that heart rate variability is higher during the night than it is during the day. Our vagus nerve is more active during the night than the day, and our sympathetics are more active during the day than the night. So what we're doing is we're turning on the sympathetics and we're saying, here we go, daytime, gotta fight food, gotta find shelter, gotta get rid of all the toxins in our body, all the things that happened overnight. We're a little dehydrated, et cetera, et cetera. And so now our body's going into a sympathetic state with the intent of clearing out and being ready for the rest of the day. So you'll see that initial dip in HRV, and that's not a bug, that's a feature. We don't necessarily, and we shouldn't always have high HRV, but we should be able to go back to high HRV over time, and the average should be higher than lower. When we look at this, Those dips in HRV in the morning are actually a sign of circadian entrainment, that we're getting our circadian rhythm back into optimal rhythm. And the key here is consistently doing this over days matters more than just doing it over a single session. Consistency is key. Consistency carves canyons. This is really, really important. In the evening, what we would then recommend is shifting to a red light. Think about the light color when you look at a sunset. What's happening in the sky when the sun is setting, as the sun is going down? I'm recording this today. It's right near the end of spring, beginning of summer. We're right at the summer solstice. We're at the longest days of the year, the longest time that the sun is out in the northern hemisphere where I'm located. And we're getting regular light even after the sun sets until 9:30 p.m. Okay? That is telling us that we're awake longer and more people are staying up later. And it's nice from a weather standpoint and being able to go outdoors, but that color is a very orangey red hue. It's a very warm color, a very calming color. And that's what we need to create in the evening from a light standpoint. When we look at the intensity of light comes in first thing in the morning when the sun rises. If you've ever watched a sunrise, it takes a few moments, not very long, for the sun to get very, very bright very quickly. I go for bike rides in the morning and I try to get out as soon as the sun is rising. And it becomes very, very bright if you're going eastward towards the sunlight. And for me, you almost need sunglasses just to be able to see where you're going between people so you don't bump into other bikers or cyclists and other runners or whatnot. We need to become aware of the fact that the intensity of light is going to play a huge role here. If you're ever wondering in terms of the intensity of light where we stand, a lit candle is around 10 lux. Okay? The lux intensity of an office space, such as the room that I'm in right now, is around 1,000 lux, 500 to 1,000 lux, depending on the type of light that's being used. Because I've got this bright light on me, it's a little bit more as well. And then we have sunlight, and sunlight is 100,000 lux. That's how bright sunlight is. So we should ideally be getting into the sunlight and using the sun, because that's what we evolved to follow, is the sun and how the sun rises and sets, and where the brightness is at its greatest. Obviously, in the middle of the day is where that brightest, bluest light is present. That's when we should be the most awake. Okay? So in the evening, we want to then shift to that red light that's telling us that it's warm, it's calm, and we can now shift from the conversion of producing melatonin from serotonin. And as we increase melatonin production in our bodies, we start to feel calm, relaxed, and ready to go to sleep. And that is part of that circadian entrainment pathway. We want to activate more vagus nerve activation. We want to activate repair systems. A big part of that is where melatonin plays a huge role, particularly in the mitochondrial space. We want to get the circadian rhythm to follow that 24-hour cycle, and the sun is going to be the best way to do that because it's natural, it's present, and it's there all the time. If you're tracking HRV, what I would highly recommend is don't panic over a single morning reading that's taken right after bright light exposure. That is expected. Look at your trends over a couple of weeks instead. That's going to be far more relevant because what you'll notice is the drop won't be quite as severe, potentially. And then your baseline HRV is going to be a little bit higher in the mornings. And if you're dealing with anxiety or some sort of hypervigilance to stressors that are around, what I would highly recommend is easing into that morning bright light rather than maximizing intensity immediately. Just go gentle. Just open the window and let the light in, and then start to go out into the light over weeks and maybe even months if need be. Don't assume that we just want to have red light all the time. We do want blue light, but we want to build to the point where your body can handle that as well. Here we go. The bottom line. This isn't at all about chasing a higher HRV number in the moment. It's about using that light timing to help regulate your circadian rhythm. And HRV will increase as a downstream marker of that regulation taking place. Again, getting back into a circadian biological pathway. That's really what's key here to making sure that this whole process works. Our morning bright light is going to be the initial trigger, and then the evening dim light, that warm light, that red light, is going to be the secondary trigger to get us into the melatonin activation. And consistency of that pattern over days, not a single session optimization, but rather every single day or as close to that as possible, is really the key. So here's our challenge for the month. I'm going to have you recommend or do this just for 1 week even. Audit your light exposure for 1 week. How often are you looking at bright light within an hour of waking or getting that bright daylight sunlight in, and dim warm light in the evening? And track, if you're tracking your HRV, track how your HRV trend shifts when you do that over the week, not day to day, but over that full week. I think that will be really interesting for a lot of people. I've had this effect therapeutically with numerous clients at Health Upgraded, where the first thing that we work on is, let's just get your sleep rhythm back. And let's start that by getting you first morning sunlight. Maybe not directly, depending on the case that we're in, depending on the situation that patient is in, but working to re-regulate that circadian rhythm first. Because we're not only consuming food in our diet, but our light environment plays a huge role in this. If you are the type of person that needs to sit at a desk all day, you've got that bright blue light, but get outdoors, get some fresh air, get some more lux of light by getting outdoors, by taking a break from your office space. And if you're using your computer or devices later on in the evening, try to put on light filters onto your phone, onto your computers, or consider using blue light blocking glasses, which are really wonderful tools to help to decrease the amount of blue light that's entering later on in the day, because all of this artificial light is quite junk light, and we want to really focus on building towards getting natural light, because that is part of your diet as well. HRV is affected by light, and your ability to increase your HRV and get as close to a maximal number and as far from zero as possible is absolutely linked to your longevity. It's absolutely linked to your overall health. And I think this is an important feature, an important pathway in the entire ability to regulate your healing. I hope you've enjoyed this episode and learned something from it. Bright light in the morning, dim light, red light in the evening. Decrease your light exposure from artificial. Work towards getting light from an outdoor source, from the sun itself, and that's going to be the best tool for you. If you've learned something from this, please share this episode with one person who you think could utilize this information. Thanks for listening. We'll catch you all on the next one.